So I sent 5,000 bots on my own website to simulate a traffic spike and see if I could handle the traffic. In this video, I'll explain to you how you can handle variable traffic to your service with Kubernetes autoscaling. We'll start with a brief walkthrough of the plan and the architecture here. Then we'll go through how I set up an autoscaling deployment on my Kubernetes cluster. And lastly, we're going to do a live load test with case 6 where we actually send the bots and watch the autoscaling happen. And by the way, if you're new here, my name's Josh. I'm a site reliability engineer, and I make videos about anything DevOps related. So here's what our infrastructure might look like to start. We're going to have a service, and this is going to be externally facing as a load balancer with a public IP that is accessible. And that's going to be where I connect to my website. Then I'll have a Kubernetes deployment with horizontal pod autoscaling enabled. That's the key there. So we're going to start off with a minimum of 2 pods. So each of these pods will have an instance of my web application running, and we're going to allow this thing to autoscale up to a maximum of 100 pods if needed. Then I'll be running case 6 from my local machine, which is a script that allows us to simulate users. So I'm going to simulate 5,000 users at once connecting to this service, which is hosting the website. And then as that happens, as the users are connecting, it's going to overload these pods because they can't handle all those connections at a single time. And it'll turn into something like this, where we scale our pods from 2 all the way up to the maximum of 100 pods. Okay, so we're now in my terminal. Let's go ahead and we'll start off and I'll show you what resources we have. So just spawn up this Kubernetes cluster. I will do kget pods-a, and here's everything in my cluster. The main thing is that we're going to use Flux CD, and that's managing our development namespace. And then we're going to look inside of the development namespace, and that's where everything's really going to happen. So if I do kget all-n development, and so we'll see here, we have 2 pods right now. They're both named CloudZap, Helm, CloudZap. These are my web app that is running as containers inside of these pods. And then I have my service, which is the load balancer, and it has an external IP, which we'll get to in a second. And this load balancer is acting as a reverse proxy to send the traffic back to my pods and distribute across them evenly. We then have a deployment here, which is how we're managing our 2 nodes. And then lastly, we have this horizontal pod autoscaler, which is what we described before. So this is where you see here, I set the CPU target to be 60%. And if we hit that 60%, then we need to scale up. So we'll always have 2 pods minimum. But if we ever cross the average threshold between the 2 pods, because remember the traffic is split between them, once we cross that 60%, that's the time that we want to start scaling up. 60% might be a little conservative, but you want to set it somewhere like 60 to 80% to make sure that you're giving enough time to spin up a new pod and distribute that traffic again before you overload one of your pods and it goes down because it can't manage the CPU anymore. So then if you look here, we have min pods is 2, max pods is 100. And then last thing, if I do kget nodes, we're going to have 3 nodes here right now. So these are the actual instances. I'm running this on AKS. So we have 3 nodes that our traffic will be split across, and they're small nodes. Okay, so last thing, let's go ahead and check out our... So in my Chrome tab, I'm going to go to http:// and that is not the IP. So we'll do http:// and then put in the IP address of our external IP. And notice it's not HTTPS because I haven't set up SSL on here. But now here's my website. So this is what is running on those pods. And so we're reaching the service right now, and that's distributing us to the pods. Okay, next on the list, we're going to go ahead and use case 6. So case 6 is a testing software that is created by Grafana. It allows us to create virtual users and then test HTTP requests to a certain server or multiple. So this one is extremely simple. We are just testing sending users to the homepage. They're not doing anything. But if you were, say, you're running an e-commerce store, you could send users to the page, have them add to cart, have them check out, all of those sort of options. You're able to actually embed that. So that way you can test what if we have 100,000 users out of nowhere come and try to add something to their cart. Is that going to fail? Because that could be a huge revenue leak. Getting into this one, what we're setting here is we have the VUS that is virtual users. So we're going to start with 100. That will be our baseline. And then we define stages for what this test should be. So in this stage, we're going to do a duration 1 minute for target. We're going to ramp up to 1,000 users. And then we're going to go after that 1 minute for 3 minutes at 5,000 users. And then we'll go back down to 0, which would be the 100 baseline. And then the last portion here, we just have the function where we define, it'll be an HTTP GET request to our IP that is our service. And in between each of them, we'll sleep for 0.1 second. So with that said, let's go ahead and get into this test. So if I come back to my terminal, I'm going to switch over here now so we can watch both. So I'm going to run my K6. So I'm going to do K6 run and then the file name. And we'll start. So here we go. Now you can see the scenarios. The max here is 5,000 VUs when we hit the peak. And it's going to be 5 minutes and 30 seconds. So now I'm going to come back over to my other terminal while that's running. Let's do kget service -n development and just check on this. So we still have one service, as you see. Here's our external IP. And then let's check on our pods. And there we go. We still have 2, so it's handling the users at the moment, which it looks like we have 580 right now. And let's just do get all for this development again. And so the other thing we can see now, CPU is at 3%. So as this continues, we should see the CPU start to ramp up. Okay, so we just passed the 1 minute mark. So now we should see this continue to ramp up. We're up to just about 1,200 users at the moment. Okay, there we go. So now, because we're at 1,600 users, there's now 2 more containers being created. And they're updated. So now our CPU is at 151% out of 60%. So we've maxed out our CPU and it happened very quickly. So now the pods are trying to scale horizontally to catch up for this traffic. Okay, we just hit 2,500 and you'll see here now we're getting some problems where it's connection reset by peer. So the service is actually starting to have problems. Let's check our development. We're still at 6. Our CPU, unfortunately, is not updating for the targets here. Oh, it just did. Now it's down to 120. So you can see we have 6 replicas now. And because we have that 6, it distributes the traffic better. So it's down to 120% from 151. Are we going to create any more pods? We're actually getting some restarts too. So even this, it's not scaling fast enough for how many users we're going up to. So the site is still working for me. It's just a little slower on the load. You can see that. Let's come back to our terminal. We're up to 4,000 users now. And you can see even my Kubernetes CLI is getting slower. So now we're at 133% out of 60% target. We should be seeing another replica spin up here. We're just about to reach 5,000 users here. Let's go ahead and get our pods again. And you can see how slow it is now. My Kubernetes cluster is really slow to react to me just because there's so many requests coming into this. Oh, wow. And there we go. We just scaled up a lot. So yeah, we can see it actually, the last time, I don't know if this is going to be accurate, but it says 133% and we're up to 14 replicas. So that's the amount of traffic that we're managing right now. It looks like we have 40 seconds left. The VUs are actually starting to go down here. So we should see the CPU target start to scale down. And once that scales down to a certain point, we should see our number of replicas start backing off as well, back down to that 2 when we have no traffic. So there's our CPU down to 120. And there we go. Our test finished. So here's some of the results of our test. There's a lot of data you can get from this. Quick note here. You can actually integrate this. Sorry about that. My camera was blocking. So here's the data if you want to take a quick look at it. There's a lot of data here, and then you can also set it up so that you can export it to a database. You can export it with Prometheus Cloud, and then you can visualize it with something like Grafana, which is why they created this. And so now that that's done, let's go ahead and check our pod again. And there we go, down to 55%. Still have 14 pods, though. So we should continue to see this drop now that we don't have any traffic flowing to the site, and hopefully our number of pods gets scaled down. Okay, so we're going to give it a little bit of time to scale down our pods, but if you're familiar with how Kubernetes is structured, you're probably thinking, okay, that's great. The pods are auto-scaling, but the nodes are what cost you money, right? So what's the actual benefit here? So the thing we can do now, we can combine the horizontal pod auto-scaling with node auto-scaling that's built in with most cloud providers, such as Azure. So I'm going to come in here and open up my resource group, and here's my Kubernetes cluster that is currently running. And this one does not have that node auto scaling enabled, but where you can enable this, so you create a node pool, and that is, it defines what type of node you want to run on, that being the size and the other like virtualization options that you get with Azure or insert cloud provider. This one just has target of 3 nodes. So these are the 3 nodes that we showed if you do kget nodes. But we can actually change our node pools to have auto scaling enabled. So you'll see I can scale this manually myself if I wanted to do that. Okay, so let's come back. It's been a few minutes. I'm going to get my pods within my development, and there we go. We have 2 pods. You can see age is 12 minutes. Let's get our horizontal pod autoscaler. We are down to 1% because there's no users accessing this. And we are back at the minimum pods with 2 replicas. And it's 25 minutes, so that took about 5 minutes from the last one, or about 10 minutes since this test has stopped to go from 14 back down to 0. As you can see from this video, autoscaling in Kubernetes is really one of the key benefits to running it. When you're able to set up these horizontal and vertical pod autoscaling as well as the node autoscaling, it gives you so much flexibility to be able to handle variable tasks like this. And you can really benefit from that elasticity of the unknowns of when your users are going to spike versus not. So one thing I wanted to add here, I actually failed an interview with SpaceX because I did not know how to do this. So the interview question that I got, it was such an interesting one because it brought so many different things of architecture in. I was basically asked if we were looking to start up a new part of the company and Elon wanted to fund it with selling hats. So we had a non-existent website and we were going to just start selling hats overnight. So the question was based, I ended up asking about how many users should we be expecting, and he said maybe about 50,000. So what would happen in this theoretical scenario was that Elon was going to tweet saying that they were selling hats, and at the time of that tweet, we were going to go from 0 users up to somewhere around 50,000, but we didn't know exactly. And we needed to be able to handle that both directly from the start, but also scale it if we had more or less than that. So now I know the answer to the question. What they were looking for is some kind of architecture like this, where you have that horizontal auto scaling so that we can expand as our traffic comes in. But we also need load testing. I had never heard of load testing at the time, especially in this sense. But what we could do is, like we had 5,000 users set as virtual users in this scenario, we could set that to 50,000 and then trigger the run and say, let's run it for an hour and just see how the Kubernetes cluster does. Are we losing users? Because, I mean, if they're coming to buy a hat and we lose a user because the site's not loading, like every single time, that is money just lost. So I learned a ton from this experience, but it also taught me to learn things like this, where we could actually now send that request with 50,000 users and just track the data over that hour, see how our cluster does, see, do we need to create more nodes? Do we need to create more pods? Like maybe we should start with 30 pods or 300 pods. We don't really know. Maybe our pods, maybe we don't need more pods, but we need to scale them vertically, which would give them more CPU and memory per pod. So all of these questions, you can kind of come up with the theories of what you should have, but the only way to really know is by doing this load testing, and that's why this is so great.